fellow classmates, we will continue to learn knowledge of sinusoidal alternating current, discuss the mystery together. We studied inductive elements through a single parameter, alternating current. The relationship between voltage and current at its two ends, and the characteristics of inductance components last class. In this lesson, we study capacitive elements pass through a single parameter alternating current. What is the relationship between voltage and current at both ends? Is it the same as the inductive element? With the question, let's start today's learning. Capacity cell is a kind of element that can store electrical field energy. It is an idealized model of an actual capacitor. That is, the leakage phenomena of capacitor is ignored, nor does it consider the loss of medium. The shape of its capacitor, as shown on the left, only when the voltage across the capacitor. When there is a change, the capacitor is charging or discharging, thereby forming a charging and discharging current in that associated reference direction. Relationship between voltage and current at both ends of capacitor, I equals C du dt, that is, the current flowing through the capacitor, is proportional to the change rate of voltage across the capacitor. When the capacitor passes through direct current, its voltage change rate is zero, so the current on the capacitor is also zero. Zero means that the capacitance is equivalent to an open circuit or an open circuit. In other words, when DC voltage is applied across the capacitor, capacitance is equivalent to an open circuit. In the capacitor circuit shown in the left figure, let the voltage across the capacitor, U equals Um sine omega t. In this voltage expression, the initial phase of the voltage across the capacitor is zero. According to both ends of the capacitor, relationship between voltage and current, it can be deduced that the expression of the current on the capacitive element is I equals C du dt equals C du m sine omega t over dt equals to omega cum cosine omega t equals to omega cum sine of omega t plus pi over 2 equals Im sine omega t plus pi over 2. Judging from the current expression, the initial phase of the current flowing through the capacitor is 90 degrees. Its voltage and current waveform diagram, as shown in the following figure, voltage U and current I cross the capacitor. It is also a sine with the same frequency, but the current phase the leading voltage is 90 degrees, or half pi. From the capacitive element, expression of current omega cum sine of omega t plus pi over 2 equals Im sine of omega t plus pi over 2. It can be seen that its voltage and current, numerically the following relation is satisfied. I equals omega cu, or U equals 1 over omega c. I analogously let xc equals 1 over omega c equals 1 over 2 pi fc. Where x sub c is called capacitive reactance of the capacitor, indicates capacitive obstruction. Current capacity, the unit is ohm. Its value can be seen from the figure below. Not only related to the capacitance, it is also related to the frequency of the circuit. The relationship between voltage and current can also be expressed by phasor. Its maximum phasor relation, maximum voltage phasor, equal to the voltage maximum initial phasor 0. Current maximum phasor equal to the current maximum initial phasor of 90 degrees. It is also equal to 90 degrees in the initial phase of the effective value of omega c voltage. It is also equal to J omega c multiplies the maximum voltage phasor. Similarly, effective value phasor relation, current effective value phasor, equal to J omega c multiplies voltage R amps phasor, voltage across capacitor. The current phasor diagram is shown in the figure, also can be seen from the figure. Current phasor on capacitor. Leading voltage phasor 90 degrees. So the voltage Rms vector, it can also be expressed as the effective voltage phasor is equal to J capacitance multiplied by current Rms phasor. Current effective value phasor. Phasor equal to the effective value of voltage divided by minus J capacitive reactance, also equal to the effective value phasor of J voltage divided by capacitive reactance. Effective value of voltage across capacitor, effective current value, and capacitive reactance are as follow. I equals U over XC. Next, we will study knowledge about the power of capacitive elements. First, let's learn the instantaneous power of the capacitive element. Instantaneous power of capacitive element, Pc equals Ui equalsUm sine omega t times Im cosine omega t equals Ui sine 2 omega t. Instantaneous power waveform diagram of capacitor as shown in the following figure. In the first and third quarter circle, capacitance slave power supply, obtain electrical energy and convert it into electric field energy. Capacitor charging power is positive. The electric field energy stored in the capacitive element, absolute value of capacitor voltage, increased from 0 to the maximum value. electric field is established and gradually strengthened. The electric field energy increases from 0 to the maximum. In the second and fourth quarter circle, the capacitive element is in the discharging state. It converts electric field energy into electrical energy, return to circuit. Power is negative. The voltage is reduced from the maximum value to 0. Electric field disappears. The electric field energy becomes 0. It is also known capacitive elements do not consume energy. It is only half energy exchange, with the power supply exchange scale expressed by reactive power Qc. Let's learn about it. Average power on capacitive element by calculation, the average power on the capacitor is 0. From the above analysis, we can see that capacitive elements do not consume energy. It only exchanges energy with the power supply. The exchange scale is expressed by reactive power. Capacitors are energy storage elements, store electric field energy. So far, we have studied pure resistance, inductance, and capacitance element. With a single parameter, characteristics and functions of sinusoidal alternating current. Now, we made a summary as shown in the following table. All the knowledge points in this lesson have been learned. In order to deepen your understanding and mastering knowledge, there are 2 questions below. Classmates, I'll see you next class.